Welcome to another video in this series on water analysis, and in here we're going to be looking at the factors that control, or determine I should say, the concentration of ions in water bodies. We've looked at how we can test for ions in water bodies, but now we're going to be looking at what are the situations that cause the concentration of these ions to fluctuate. And usually water testing and these factors are put together in a scenario when it comes to questions. So the questions will give you a scenario. They'll say, okay, stream A, B, C and D, determine the quality of the water by looking at the tests. And so you look at test data and then they'll say, well, what could have caused these issues? And this is where you need to understand this concept as well. So let's draw up a table, because there's going to be a few and we want to make it nice and organized. So I'll draw up a table and I'll be back to add some details to it. All right, let's now examine the first of these factors. So leaching is a process whereby you get the release of these ions, usually dissolved in water, that come from some sediment base and go into the water table. And so when it rains, okay, the water that goes along the surface of let's say farmland or any land that's near a water body is going to have some degree of leaching. Some of surface ions, not a lot, but some surface ions are certainly going to be in there. There might be some sulfates if it's near farmland, for example. So you get surface ions dissolve in it. Then if you get deeper penetration of rain into the soil, so if you get deep leaching into the soil or the water enters aquifers, then you're going to get a lot more minerals in your water that gets to the water body. Okay, so what does that mean? Well, it means if you get a lot more of these, you get an increase in your total dissolved solids, right? So you're going to get an increase in total dissolved solids. You're also going to get an increase in turbidity as well. So you're going to get a lot of, with the rain coming off, you're going to get a lot of turbidity aspects in the water. So not only will be your total dissolved ions in there, but you're also going to get insoluble particles, and those insoluble particles from dirt, etc., that's going to increase the turbidity. Okay, now what other effects could that have? Well, as we've discussed, if you increase turbidity and total dissolved solids, that's going to affect your dissolved oxygen. Okay, so another factor, so another thing there we can say that with this leaching is that depending upon the ions, it's going to affect pH of the water as well. Okay, so the pH of the water will change when it rains depending upon what ions are affected as well. Another factor that can affect the concentration of ions is the temperature of the water. Now, we normally think of temperature of the water in terms of just the normal temperature from the sun. So if we do increase the temperature of the water, then we increase the solubility of the ions. We also can affect in terms of, well, not ions really, I'm thinking of dissolved oxygen there, but you can also get water temperature being affected by industrial waste. So if industrial water, so with industry sometimes they use water in their cooling systems, and if that hot water is released into the local water body, it will increase the temperature of the water. That will cause more ions to dissolve, therefore increasing total dissolved solids. So we've got some agricultural land here and farmlands. That's going to increase nitrogen and sulfate. So we said before, from fertilizers, that is going to cause possible enhanced nutrients entering the waterway. So these are nutrients, which may lead to algal blooms. Okay, so we're going to look at eutrophication in another video. But if we get a release of, or leaching or runoff of these ions, it can increase the nutrient content of the water. We're running out of space down here, so we might have to rub this out and fill out the next couple of rows, so be back in a tick. Okay, so we've just rubbed out 2 rows and we're going to add another one, human waste. So human wastes not only have nitrates, they also have phosphates. Okay, now human waste, of course, is okay, so we've got the first 2 rows free here. So human waste contains nitrates and phosphates, And that's going to have a problem in terms of bacteria as well as toxins, etc. So if we write bacteria there. Now that can be human effluent and water waste directly released into the stream, or it could be due to some type of processing that is skipping a step, for example. But human waste entering causes bacteria numbers to increase, and therefore that can increase BOD, right? And that can release to toxins and of course disease. Then we have industrial. Now what I mean by here, I'm talking about heavy metals. Right, so we can have heavy metal ions entering, we can get lead, we can get mercury, we can get silver, aluminium. Okay, so all of those ions can enter, and of course that's going to have a problem in terms of heavy metal poisoning. And we talked about that one in the previous section. So as you can see there's quite a lot of factors that can affect the concentration of ions. And like I said before, when questions usually arise, they give you a scenario, they'll give you some data to analyse, and then they'll say what could have contributed to some of these levels. So they might say, well, we have higher concentration of metal ions, what could be happening at this site here, site A? You might say, well, upstream from site A there would be some industrial effluent released. Or you might say the BOD has increased at this particular site, what could have caused that? And you'd say, well, upstream from where the measurement was taken, there may have been some human waste or some animal waste from farmland that would cause an increase in BOD. So use this information with the information we've previously done, and we'll do some questions, specifically how we can do scenario answers using this information. Okay, see you in the next video.